In this video, I'm going to go over how to solve more complicated equations, especially how you would show your work on these problems. This chain of events, this is a guide to how you could solve every equation. Now, some of your equations, a lot of them, you won't have to do every one of these steps. But if you follow these steps in every one, saying yes or no and moving on to the next thing, then you'll be able to solve even the most complicated equations. So the first thing you would do when looking at an equation is check to see, can you use the distributive property? If you can, then you do that. And then if you can't, then you move on to the next step. Can you combine any like terms? If yes, you do that. If no, you move on. And in each of these steps, once you do it, then you move to the next step. Are there variable terms on both sides? If yes, collect them on one side. If no, move on. And if yes, you do it, and then you move on. And then we come down here and we go to, is a number being added or subtracted to the variable? This would be in a one or two-step equation. If yes, do the opposite. And then is the variable multiplied or divided? If yes, do the opposite. And then you check it with substitution. All right, let's look at some examples of this, starting from two-step equations and then getting to more complicated ones. These are actually from a worksheet that you already did, and you should already know how to do these. So the first one is 5y minus 2 equals 28. We're going to go through this using these steps. So the first one says, can you use the distributive property? Remember, distributive property is when you have something like this with the parentheses. There's none of that in this one, so that's a no. So we move to the next step. Can you combine any like terms? That would be like 3x and 5x on the same side of the equal sign. None of those in this one either. Are there variable terms on both sides of the equal sign? That's when you have like a 3x plus something on this side, and on this side you have another x term. There's an x here and an x term here. We don't have that either. So then we move all the way down to here. Is a number being added to or subtracted from the variable? Yes. Here's the variable. It's y. We have a minus 2 being subtracted. So we're ready to do some work now. If yes, do the opposite to both sides. So the opposite of minusing 2 would be to plus 2. So on your paper, you have to write plus 2 under the minus 2 and under the 28. And then we simplify what we get. 5y minus 2 plus 2, that's just 5y. And 28 plus 2 is 30. And now we're ready to go to the next step. Is the variable multiplied or divided by a number? Yes, it's 5 times a number equals 30. If yes, do the opposite to both sides. So the opposite of multiplying by 5, that's what 5y means, is to divide by 5. So 5y divided by 5, that cancels, and we just get y. 30 divided by 5 is 6. So we did this one. And then does your answer check using substitution? So now we take our answer, which is 6, and we put it back in here into our original equation. And we go 5 times 6 minus 2, and we want to see if that equals 28. So 5 times 6 is 30, minus 2 is 28, so we do get 28 equals 28, so it checks. So we're all done with these steps for solving this two-step equation. Let's look at number 2 and do the same thing. Can you use the distributive property? Nope, no parentheses. Can you combine any like terms? Nope, on this side there's only one x and a minus 7. Those aren't like terms. Are there variable terms on both sides? Nope, the x is just on the left side. So we'd go right to this one. Is a number being added to or subtracted from the variable? And the answer would be yes, there's a minus 7. So it's 2x minus 7. So the opposite of that would be adding 7. So you'd write plus 7 plus 7. And then we go to the next step. Is the variable multiplied or divided by a number? First we have to simplify. We'd get 2x equals 7 plus 7 is 14. And then yes, we have x being multiplied by 2. So we need to divide by 2, so we write divide by 2 on both sides. And then we simplify that, and we get x equals 7. And then to check this, you would take the answer of 7 and put it back into the original equation. And 2 times 7 is 14 minus 7. And we want to see if this equals 7. So 14 minus 7 is indeed 7. So we get 7 equals 7, so it checks. Now number 3 is a little different. There's no distributive property. There's no like terms. There's not a variable on both sides. There is a number being added to or subtracted from the variable, but in this case, we have to switch the order of these two things because we have w and it has 2 subtracted from it, and then that whole thing is being divided by 5. So in this one, remember, we actually have to multiply both sides by 5 first. So these two things sometimes are switched. And when you multiply, you cancel the 5's and you get w minus 2 equals 1 times 5 is 5. And then you'd go back to, yes, there's a number being subtracted, so we will add 2 to both sides. So there are some times where you'll end up with slightly different order for these last 2 steps. All right, now when you get to the 11.2, this is in the week 14 folder, we're going to have some problems like these. These are the first few problems on the worksheet. And you're going to go through these steps and check and see which ones you'll need to do. So can you use the distributive property? And there's no parentheses, so this is a no. Can you combine any like terms? Now that's what this section is about. It's about simplifying expressions or combining like terms before you solve. So for number 1, there are like terms. We have 7d plus 2d. Those are like terms. So we can write them next to each other. And we also have minus 12 plus 3. I'm just rewriting them so the like terms are next to each other. And that was equal to 18. So we're going to do this step of combining our like terms. So 7d plus 2d is 9d. Minus 12 plus 3, that's a negative 12 plus 3 would be minus 9. And that's equal to 18. Okay, now we go to the next step because we did this step. It's all done. Are there variable terms on both sides of the equal sign? Well, we've got d here, but that's the only d there is. So we don't have to do this step. So now we come down here. Is there a number being added to or subtracted from the variable? Well, yes, we have a minus 9. So we need to add 9 to both sides. And this would be 27. So we did that step. And then is a variable multiplied or divided by a number? Yes, we have 9 times d, so we need to divide both sides by 9. And d is equal to 27 divided by 9 is 3. And then our last step is to take our answer, which we got 3. I'm just going to change the color here. And put it back into the original equation and see if we get 18. So that'd be 7 times 3 minus 12 plus 2 times 3 plus 3. And we want to check and see if this is equal to 18. So 7 times 3 is 21 minus 12 plus 6 plus 3, and I don't know if this is equal to 18. I put a question mark, and I'm still checking. And now I do the work. This is all addition and subtraction, so I'll just go in order. 21 minus 12 is 9, plus 6 plus 3. 9 plus 6 is 15, plus 3 is 18. So yes, it does equal 18. So it does check. So I did the last step too. So all of these problems will be done the same way. You won't have to use the distributive property in this worksheet. Oh yes, we will. Number 5, let's check. So can you use the distributive property? On number 5, it'll be a yes, because 10 parentheses h plus 1. So the first step on number 5, I'll put it right here, would be to use the distributive property. So we'd get 10h, because 10 times h, plus 10 times 1, minus 4 equals 76. So I'm going to Now we go to the next step, which says, can you combine any like terms? Well, yes, because 10 minus 4 plus 10 minus 4, those are like terms. They're both numbers, but we can call them like terms. Are there variable terms on both sides of the equal sign? No. There's only an h on one side. So then I have a two-step equation left, and I'll finish it by going to this step and subtracting 6 from both sides. And you get 10h equals 76 minus 6 is 70. And then from there, you just do the last step, which is divide by 10. And we'll get that h is equal to 7. So for number 5, you get h equals 7. And then you can go back and check it by putting the 7 right here. 7 plus 1 is 8. 8 times 10 is 80. And 80 minus 4 is 76. So I checked it in my head, but I did check it. So we did number 1 and number 5 on this worksheet. Number 7 and 8 are a little bit different. And there is a worksheet, there's a video already explaining how to do those problems. And you can watch that separately. That would take a little bit longer. All right, here's just some more examples. This one goes through using the distributive property, combining like terms, and then solving. In this example, you'll see that sometimes we get a decimal answer. In fact, most times in the real world, when you'd be solving an equation, you would get a decimal for an answer. Sometimes on worksheets, they're kind of artificially managed so that you'll get a whole number or an integer for an answer. But most often you would get a decimal. So it's very important that you follow the steps so that you will get the answer whether or not it's a decimal or not. So sometimes you can guess and check when it's an integer answer and you can find the right answer, but when it's a decimal, it's almost impossible to do that. So a better method is to learn these steps, show your work, simplify as you go until you get your answer, whether or not it's a decimal or an integer. These are some examples from a worksheet in the week 13 or 14 folder, I forget which one, but I want to just go through these steps that we just went over and see if we remember the steps. So the first step is to do the distributive property. So on this one, we can do that. Remember, sometimes you don't need to do every step and sometimes you do. This was the solving equations with the distributive property worksheet. So we have 5 times 1, that's a 1, is 5, minus 5 times 2w would be 10w, plus 8w equals 15. So that's what you would write on your paper. That's showing your work. The next step is to combine like terms. We have like terms because we have minus 10w plus 8w. Minus 10 plus 8 is minus 2. So now I write 5 minus 2w equals 15. You type that on your paper. The next step is to look at the variable, which is w, and to see if there's something being added or subtracted to it. Now in this case, what's being added is actually at the front. It's this 5. So I need to subtract 5 from both sides. It's being added because if there's no sign in front of it, it's a plus. So I subtract 5 from both sides. That gives me minus 2w equals 10. And then the last step is to divide by the negative 2, and I'll get w equals negative 5. On number 7, the 6 is over here by itself on the equal sign, but that doesn't matter. You can have the number over here and the variable on this side. That doesn't matter. I still do the distributive property first. Negative 14 minus 2 times minus c would be a plus 2c. Now here's the variable. It's a c. Is there something being added or subtracted to it? Well, yeah, I've got this minus 14 here. The opposite of that would be plus 14. So 6 plus 14 is 20 equals 2c. And then the last step is to divide both sides by 2, and you'll see what you get for an answer. Number 8, I think we won't do right now. Number 12, let's see what we get for this one. First step is to check and see if we can do the distributive property. 3p minus 3 times 5 is 15, plus 8. Now in this one, there are some like terms to combine. This minus 15 plus 8. Minus 15 plus 8 would be a minus 7. Then we will add 7 to both sides, and you'll be able to finish it from here. Dot, dot, dot. Finish that up. This one's not done yet either, but... All right, let's see what else we got. Solving equations with variables on both sides is an additional step right here that we haven't had to use yet. You will do that after you use the distributive property, after you combine like terms, and then you would check to see if there's, for example, an x on the left side and an x on the right side. So in this first example, there is no distributive property, and they've already checked and there's no like terms. So the next step is to get the variables on the same side, because we don't want an x here and an x here. Well, to do that, you just do the opposite. This is a plus 2x, a positive 2x, so we can subtract 2x from both sides. Then you get 10x minus 2x is 8x, because they're like terms, so you can just combine them. And then all that's left on this side would be the minus 16. And then you just solve it the same way you would solve any simple equation. On the second example, there is some distributive property, so we do that first. So we just rewrite the 3x, then we do the distributive property on the right side. 5 times x is 5x, 5 times 2 is 10. Now we go to the step that says, are there variable terms on both sides? If yes, collect them on the same side. So we have to do the opposite. If it's a positive 5x, which it is if there's no sign, we would subtract 5x from both sides. 3x minus 5x is negative 2x, and all that's left over here would be the 10. And then we just divide both sides by negative 2, and you're all done. This is the checking over here. Also, when you do problems, any kind of equations, you sometimes get a funny answer. Like in this example up here, if we combine the like terms there's no distributive property, so if we combine like terms on the right side, we get 4x minus 7x is negative 3x. So we have negative 3x plus 9 equals negative 3x plus 9. They're the exact same things on both sides of the equal sign. We can try to get the variable together, like by the opposite of minus 3x is plus 3x. And when we do that, we get 0x. 0x is the same as 0. There's no x's left. So we get 9 equals 9. That's always true. If you get the exact same thing on both sides of the equation, whether it's right here or right here, then your answer is all real numbers. Sometimes when we do this, we start solving, and we get something on the x's cancel out, like in this one you subtract 5x, you subtract 5x, and you get a false statement like 6 equals negative 10. That's never true. So if you end up with something that's never true, you write no solution. Okay, on the 11.3 worksheet, here's a few problems that have variables on both sides. And I want to start with number 4 to go over what we just talked about. There's a 5t on the left side, there's a 5t on the right side. There's no distributive property, there's no like term, so my first step would be, to try to get these, why have I done that? To try to get these together. Okay, it doesn't want to let me write, but I'm going to, there we go. Okay, minus 5t, minus 5t, because I'm trying to move this one over there, so I do the opposite. 5t minus 5t is 0t. There's no t's left. So I write minus 5 equals 7, because these are gone too. But that's not true. Not true. So you write no solution. There is no value of t that would work so that you could get 5 times that number minus 5 would also be the same as 5 times that number plus 7. Impossible. Let's look at number 1. We have a 6x here. We have a 1x here. There's no distributive property. There's no like terms, so all I need to do is subtract 1x from both sides. To get 6x minus 1x is 5x plus 3 is equal to 8. And then you know how to finish it. You would subtract 3 from both sides. It's just a two-step equation now. And you'd have 5x equals 8 minus 3 is 5. And then we divide by 5, and we get x equals 1. Let's look at number 3. There's 13x on the left side. There's 11x on the right side. We need to get our x's on the same side, so you take the opposite of 11x, which is minus 11x, and we do that to both sides. 13x minus 11x is 2x. So very quickly these equations turn into simpler equations. And then you just continue solving by following the steps that we have gone over and showing your work and just methodically moving through. And negative 25 minus 15 is negative 40. Divide by 2, divide by 2. And we get x equals negative 20. So each time you just follow the sequence, and I have added this, emailed this to you so that you can go through and print that and follow the steps. And if you do that each time and show your work, you should end up with the correct answer every time. Thank you very much. Have a great day.